Okay, so today we are going to be covering the airline flight ticketing problem. For the requirements, users can browse available flights, users can book a flight, and what's going to make this very distinctive from the hotel booking problem is that you can book a specific seat on the flight. So that makes it look a little bit more like the Ticketmaster problem. That is the favorite problem of Steve from the Life Engineered. He really likes the Ticketmaster problem for interviews. He's a principal engineer at Amazon. And so that makes that problem really intimidating for me. And I won't handle that one, but this one's kind of like midway between them. For our scale numbers we'll be handling today, 10,000 TPS for the reads, 10 for the writes. That should keep it a little bit more realistic. We're going to do a couple of iterations. We're going to first do it with no payment gateway attached. Then we're going to add a payment gateway. I'm going to do a couple of orchestration approaches. And then we're going to go ahead and scale it up to an unrealistic number if I have time for it. And here's my section for the live discussion questions. Let me know if you guys can't see anything all that well. I see we've already got some questions in the live chat. From A to D with B and C interview. Oh, right, out of scope. I'm not going to handle logistics on this, the flight logistics where you have a couple of flights to get from one destination to another. So yeah, just single source, single destination, that is going to be the scope. So I'll write that as out of scope. Logistics. We will only be handling single source, single destination. Yeah. Okay. And with that, are there any questions before I go ahead and jump into the diagram, or are we good to get started? It's just a random number that I pulled up. It's I remember seeing this number when I was working on the hotel booking problem, and you're going to get about as many flights booked as hotels. They should be about roughly the same in terms of size. When you're traveling, you know, you'll get a hotel and you'll also get a flight. And so sometimes you might not need a hotel for a journey if you're just staying with family or something, but I think they're going to be about equal. And so I'm just going with 10 TPS writes here. Yeah. I should probably go with daily active users and stuff like that. And then like try and drill down into number, but here I was just not feeling it stay or something. So I'm just going to have the transactions per second given right off the bat. And these are very similar to the numbers for hotel booking. I haven't actually seen, I actually dug through leak code discussions for the prompt for this, and there actually weren't a lot of great numbers given for the prompt. And so that's why I feel a little bit more justified in just pulling numbers straight out of my ass here, is that nobody was providing any numbers. And so I'm just making it similar to hotel booking. Okay, I'm going to go ahead and jump into the diagram now. So we're going to need to have a browser thing for each of the scenarios. I like to start with the entry points and exit points. Whoops, let's not have that there. Okay, and it's going to have 3 use cases. We're going to have listings. So that is listings / search. We have seat selection. And then we have the booking. We're going to call that ticket purchase. Okay, and you're going to need a backend for each of these. We're going to have a listings service. We're going to stick that over here. And we're, of course, going to need a database. And I'm going to call it the listings DB. We'll call it the flights DB. We're not going to try to do any kind of federation here because at the TPS that we have, you're going to be able to scale it doing just leader follower pattern. I can actually go ahead and dig into that right now. Is that you'll have a leader node, and then you'll have a follower node. And I like to draw that kind of like this, where I have like a box that is dashed. I draw it here and give it a little space. I'm gonna have dashed lines, and that's the leader node. It's going to get replicated to the followers. So let's make it not like that for the stroke style, and have it as that there. Okay, so that's the follower nodes. Your reads are going to come off the follower nodes. That's how you can scale up the reads to a higher number than can be handled on a single node is leader follower. Got that, and you're going to do the reads straight off of that. And then this is going to need a load balancer. My intention was to have a number high enough for the reads that you would not be able to handle the reads off of a single node, and you would need to do some replication here. So that's what we got here. And then if you're going to have to replicate it, you're going to have to do some horizontal scaling. You're going to need to do it over here. And then you're also going to need a load balancer at that point. So we're going to have a load balancer in there. I've been trying to get a little bit better at remembering to use a load balancer lately. I've forgot to do that for my first dozen videos or so, but now I'm trying to get better at remembering that. So there we got our load balancer, and so that should handle the read scenario pretty well. We should talk about the schema and the we need to talk about the schema. We need to talk about the DB tech choice. Okay, so for schema, for the listings, you're going to have, let's have our schema right in here. So you'll have your flights, you'll have a flight ID, that'll be like 1637 United Airlines or something. You'll have a to location and a from location. So to location, from location. So you'll have like CTAC versus what is it, SFO for San Francisco. And then you'll have the price. So say it's like how it is like a string. Data format for prices is a little bit of a contentious area. It's like I mean you can have it as double, but then you don't want to be doing math on it because that's a floating point math and all that. So it's might as well just have it as a string, I feel. Or well, actually, you might want to filter on the price. You might do a filter over the price. Maybe you could do like a string and a float, and then the string is just ensure that is properly formatted in the display. Or I don't know. I think you can just go ahead and leave it as a float, but you got to be careful with that then. So price, you're going to have a depart time, and you're going to have a arrival time. And then we're going to have that in Unix epoch time. 0, 5000, 167,000. It's let's try 16800. This would probably make the flight like a year long, which is unrealistic, but this is kind of proper for a Unix epoch time formatting. It is, I'm pretty sure it's that number of digits long. Okay, so we've got that, and then I'm going to have an available flag. So this is going to be what you're going to be hitting for. This is what you really want for the reads, where you're going to have your key range queries and your filters and stuff. And so I'm going to have an available flag. I'm going to set it with true, false, and we're going to do something with a DB trigger. But it's going to be like within the table, and the DB trigger is going to update this. So I'll make a note, updated by DB trigger, And then I'm gonna have also, we want to have the boarding passes. And I'm just gonna call that table the tickets. So it's the boarding pass. So you're gonna have something like the name or user ID field. We're gonna say that Albert Einstein is on this flight. We have a very special guest here. See a couple of questions in the chat. Does TPS mean transaction process system? So TPS equals transactions per second, and that is that's Amazon lingo. Other places like to do QPS, which is queries per second. Is another popular thing, but I spent some time at Amazon, so I like TPS, which is transactions per second. Okay, good. Thanks. So somebody actually addressed that. Can you give any reference for when we say we need more than one replication factor for DB? I've heard a rule of thumb of somewhere I saw 1000 TPS per node. And you should also do n plus one replication factor so that you have at least one failover node. You like just barely are able to hit 1000 TPS on a node. You don't want to be like right at capacity on the reads. And I think 1000 is kind of high for a single node. So that's why I'm thinking that 500 is a little bit more comfortable. You don't want to be like right at the capacity for a single machine. And I've heard 1000 TPS is like right around the capacity. Maybe I should have gone higher on the reads, but I wanted something higher that you would need to like split it. So maybe like 5000 TPS or something. I didn't think through it a lot. I just wanted it to be high enough that we're going to have to do horizontal scaling on the reads while not having to do that on the writes. So this is a little bit realistic on the numbers. And then I came up with two just off of one node can handle that, but you should do n plus one replication so that if one fails, it doesn't overload everything. Yeah. And then, I mean, you also have to handle leader fallover. If your leader fails and the hard drive gets stuck in 6 feet of mud, which I've heard is the rule of thumb for how you're supposed to think about failure scenarios. It's going to fail over to one of the followers, but so you need at least one follower for that, and then n plus one for the reads, because you're going to have all those reads just off of these two. Yeah. Okay. Other questions. Is there a general threshold around which a single master writes becomes the bottleneck? So I like to use 1000 as a rule of thumb. That's just, I didn't look into that whole lot. It came from this reference in Alex Shu's book for the digital wallet chapter of volume 2. So I think I got this from Alex Shu's volume 2 digital wallet chapter. And he had some reference to something I feel like HPC-E. And I'm just stuck with that. Really, you should be doing benchmarking though, because it's going to vary a ton depending on your workloads. Are you going to be doing transactions? Are you going to be doing a whole bunch of key range queries? Are you going to be doing scatter gather hits against Elasticsearch? You should be doing benchmarking. Specific case though. Yeah. Flights DB be some search index like Elastic? There we go. That is a great question. I was just about to get to that. Yeah, I want to cover DB tech choice. I think this is we can pause the schema for now and go ahead and talk about the DB tech choice. So there's DynamoDB, There's a PostgreSQL. You've got Elasticsearch, has triggers. PostgreSQL also has triggers. Elasticsearch actually does not have triggers. You can't do DB triggers on Elasticsearch. And then I don't think this one has any, it doesn't have any geo stuff. Like this one has R trees, which is nice for geodata in case you have to do that. Elasticsearch has quad trees, no 2D index support. It's just straight B trees to my knowledge. And then another thing I was kind of considering Redis, which has geohash, but it's no secondary index support. So we're kind of down to either Postgres or Dynamo, and I'm feeling Postgres. It's you can do transactions. It just gives me more confidence with the transaction support. A lot of places that like to do, I think in airlines and hotel booking, a lot of shops use PostgreSQL. I'd prefer Postgres over Elasticsearch because of that trigger support. And I think we're only going to have like 6 fields. DynamoDB has a limit of up to 20 secondary indexes. And then PostgreSQL, I'm not familiar with the secondary index limits, but it does support secondary indexes. And then this one, of course, does as well. It supports like there's like no limit on secondary indexes. But I'm feeling PostgreSQL a lot here. DynamoDB is probably fine as well. It's just that we don't really need that kind of scale. And a lot of the shops I've seen will just use PostgreSQL in this kind of use case. Yeah. You could maybe use it as a heterogeneous replica. You could maybe have these as Elasticsearch, and then this one is PostgreSQL or something. So that way you don't have that as much of an issue with the lack of trigger support. Yeah, Elasticsearch is really nice when you need tons and tons of secondary indexes. So it's really solid for that. But I think we're going to get what we need off of PostgreSQL, and then if you're feeling it, Elasticsearch as a replica could be kind of nice. Yeah, but we can probably get what we need with Postgres. Let's go back to the schemas. There's a question on, hold on. What is secondary indexes for? Well, so normally you only narrow down by the primary key. So it's like when you need to search on something or like filter down other than the primary key. So by default, the B tree or LSM tree or whatever is what you have set up for the primary key. But then we're going to probably filter down by some of those other attributes, like the to location and from location. And if you don't do that and you don't have the flight ID, and you say the user will say something like, I want a flight from Seattle to San Francisco. I want it to be under $500, and I want it to be on a certain date range. So you're going to be filtering down by all 5 of those. And then I think this is going to be our primary key, but so like they don't have a specific flight they're looking up. So they're just going to be using these. If you don't add secondary indexes on it, it would mean that you'd have to do a full table scan, which is really, really expensive. So that's why we have some secondary indexes. And you're only going to want the available ones too. So actually, we're going to use 6 different things that we're narrowing down by. Yeah. Okay, I'm going to jump back to the DB schema. We're going to need the name for the ticket. You're going to want the flight ID. And then that will probably have some gate information as well. You can probably have that on the flight ID. And I mean, your ticket itself, when you print it off, is also going to have it. But I mean, for the actual DB schema, you probably don't need to inline all of your flight info. So you probably can just get away with having your gate info. So it's like to gate, from gate. So it's something like 17C, and then you have like 20A. You're not really going to be searching over that. I guess you can store it in the flight section. Price is probably going to be on there. What else did I need? Oh, plane type ID. What type of plane is it? It's going to be there, but I don't think you would you would display it necessarily, but I think this would be a useful place to have it. And I'll show you why in a minute. Is that I want to have like the seat mappings. So you'd have like a 787, like Boeing 787 as the type, and then I want to have this other thing that you're going to like cache, which is the plane. It's the seat mapping table, where you're going to have primary key of the plane type ID, and then you would have a bunch of seats like 37A, 37B, etc. And so you have all available seat options for each plane type. So if it's a Boeing 787, you would know that it's going to come out to like 80 seats. And then you're going to have that seat option stored on your ticket. It could be unassigned. So you're going to have something like 37A/unassigned. And I think, so while you're paying for it, you're going to have a status over here. So it'll be requested, like payment requested, payment authorized, and payment successful. And it's not going to be on your boarding pass, of course. It's just tracked there while it's going through the payment. And you're also going to want to have some counters for the ticket, for the number of seats, for the seat mapping, to determine whether or not it's going to be hit as available or not. You're going to need some counters. Okay, so those are going to go on. I think you can have those on the flights, or you would want you want the seats by the class, like economy, business, or like first class. So the flights. Oh, I see we got some more questions in the chat. For updating seat counts after purchasing a ticket, and it's going to do an async update of that. So it's within database DB triggers, as opposed to doing CDC here. We're not actually going to do CDC. We're going to do a DB trigger that is just going to be here. And so then it'll be triggered off of a, so it'll be like a purchase update. It's a ticketing update. And then you want to update the inventory. And then it'll be inventory/counter update. I'm going to do that off of a DB trigger. So unlike my other videos where it's distributed, I got a lot of flack about doing, wow, that is such a pain right there. Okay. I got a lot of flack about doing federation on my hotel booking approach, and I kind of agree with it. And I've kind of updated it in my notes for that problem, is that you didn't necessarily need to do federation there. And so here you don't need to do federation either. If at all, when we scaled up for the rights, what we're going to do is we're going to shard it over the flight ID, I believe. Let's go ahead and mark that as the primary key. And so you're going to shard over that, and then you'll just be able to handle the distributed transaction within a single node, as opposed to having to distribute it over multiple things and do a distributed transaction, which is bad. So that'll be how we shard it. And then for the ticket, I think, yes. So I think we would shard. I would like this thing to be what we shard over for that table. So it would maybe be a chunk of the primary key. So your primary key would consist of both flight ID and the name in order to properly. Well, and then Albert Einstein might be taking a couple of flights. So, you got to have, you can't just use the name for sharding. You have to use the flight ID and the name in order to identify a record uniquely on this one. And then this would be how we would shard it, if at all, which would be our follow-up. You won't need to shard it typically, but I really like to handle that makes the problem more exciting and spicy. So that's why I'm going to do that as a follow-up at the end if we have time. Okay, yeah, cool. We got that. Number of available seats can be one. That, like, I'd imagine on the flights table is what you meant. Flights. Yeah, I'm thinking that should definitely be an attribute on the flight table on top of the available thing. But the issue is that I think it might need to be at the class level. No, we don't need to have it at class level. We don't need economy. It's just the general number of seats, because that would be because that's all you need for determining whether or not you'd actually be able to get a ticket with a specific flight. So I think we do just need the overall seat count. And do we want to have it count up, or do we want to have it count down? Well, so we can have the plane type IDs max count could also be stored on the record. That could help with the, well, so we have two approaches here. Seats count can either count up or count down. I don't want to get super hung up on that. So instead, I'm just going to have it as 0 to start with, and it'll count either way. And then this is what's really important for the filtering. You can combine it with the seats count if you make it the seats count available as in you're counting down, and then if it's 0, you would filter it out of your results, and so then you wouldn't need to have an extra attribute for available. However, that there's a chance that might violate the concept of a single responsibility. You don't want to have a field that's handling multiple responsibilities, at least in code. In databases, the concept of normalization, which is maybe a little bit different. And so, but I mean, you've got multiple options here, and whether you want to count up or down, I don't really care, and I don't want to get too hung up with that. But yeah, I think that would be a good idea. And so you're going to do the DB trigger from the tickets over to the flights, I think, for updating the seat count. Yeah. We'll maybe get to there later in the video and dig into it more. See more comments. Probably when the flight is completely booked, when the trigger will remove it from search or something. I didn't know we do that with DB triggers. Number of available seats me on flights. Yeah, okay, cool. Thank you. Thank you for elaborating. Yes, okay, so we're doing that on the flights table. Why do we need name on? I'll split between user ID and, yeah, so I don't think we should inline the entirety of the user info into the ticket itself. So we could instead have user ID, and then there could be an entirely separate users thing where you have the this one could maybe even be federated. I think users could even be federated. 1237. There we go. Yeah, I like that. That's okay. Somebody also had a good point that it could also be a guest. Like when you're filling out the booking, you don't necessarily have to be signed in. You could have a user info ID. That could actually be a more accurate way to do it. Because when you're filling it out, it still is going to ask for your name, and then that could even be, or you could even, and I don't know if you really need to inline it or not. It's another option is that you could just have treat each one as an independent thing, and then you could inline all that info into the ticket. What's going on with, come on. I don't like to handle fundamentals. There's a lot of videos out there about that. Alex Chu actually had Alex Chu has a wonderful diagram for this. I went into a little detail on the DB trigger thing and the internals a little bit on like who supports the quad trees versus R trees. There's not any phenomenal resources on that yet. I was even thinking that I might want to just do that. Make my own infographic on it just because it's not really out there and it's really hard to aggregate all that information together. I've also gone into I've gone into that in other videos and I don't want to go off too far on a tangent on that. So I'm sorry, I'm not going to handle that here in line. Maybe I'll make a video specifically about that sometime. But I mean, there's other ones out there that handle that. Okay, cool. Let's go back. So have we handled our schema completely yet? We have seats count. I think we're looking pretty solid. I think we've got everything I can think of. Yeah, we can go ahead and get back to my diagram. So we've got that. Let's maybe copy it. This is like maybe a good checkpoint for I can start maybe trying to give you guys a link to the Excalibur in the comments or something. I do that for the people on Discord. I should really probably do that for the YouTube audience too. So we've got that, and then we want seat selection. So for seat selection, I have that seats map. There's seat selection service. Let's make that. So we're going to have that, and it'll read from the flights DB. And you'll also have this, you could also, so that would be like a key range query of like one table. And then you can even have a seat mappings cache is something that I was thinking of that can be directly on machine. Although if you're, it would at least remove the amount of DB IO that you'd have to do. That's also a very common bottleneck is how much information that you're sending over the wire between the database and the service. DB IO throughput can easily become a bottleneck. And so that's why I'm thinking that you might even want to have this seat mappings cache. And it can either be like a Redis like local instance that's like a daemon or like a co-deployed thing to this, where you have just for each plane type ID, the like all the seat numbers that you options that you would have for it. Because like how many different types of planes are there? Like maybe a few dozen or dozens, hundreds. I'd imagine you can very easily fit it in under a gigabyte and just a gigabyte's probably like way more than you would even need for storing it. And so it just can get deployed in there. You can even do like a Java bean possibly. So Java bean or a Redis instance locally deployed could probably work for that. And then it would really reduce the IO for, you wouldn't have to pass the seat mappings as well. You would only need to pass in, the the booked seats. You only need to know, you have to only do a QRange query of that for the tickets to retrieve all of the booked seats for a specific flight ID to present the options. And then you're going to pass that off to the browser. There. Okay, and we also want to have our booking service. We're going to have our booking service. That one is going to do a bunch of stuff over there. You're going to want an item potency key for, we're going to have some nasty partial failure scenarios possibly. So you would want a item potency key that would come off of, like when you're loading up the page, you might request it off of so you have a bunch of static assets, but it would be, you either have it generated on the browser itself, but you're going to need to have some kind of item potency key. When you've got the page loaded up, we're going to use that for deduping the transactions in case it has a partial failure. Item potency key. So it can either be server side or client generated. If they screw with it on the client side, well, that's just on them for, why would you need to, there's no benefit to doing that as a hacker, because then you would just result in having multiple tickets that you just paid for. You're self-inflicting a double charge if you try to do something like that. The only reason why you would screw with it on the client side is self-inflicted double charges. So it's I don't care if it's client generated or not. That might even make sense to have it client generated. And then so we got the booking service, and it is going to do a transaction to the flights DB to book the thing. And we're also going to want to talk about the payment gateway. That's something we're going to want to integrate. But for now, we're just going to say that it is going to create a ticket record. Oh, that's a thing we need to store on our ticket is the dedupe ID, the item potency key. ABC, 3, ABC. Yeah, we want to store it there. And so when we're doing our transaction for creating the ticket, we're first going to do a read and check that this doesn't already exist on the table. We'll first do a read and check for that. And if it's not there, we go ahead and write it. Yeah. I see more questions. How can a system more creative on dabs? No offense on various or Swede, just curious how Apple is more creative. I don't know what you're asking for there. Sorry. Feel free to elaborate in a follow-up question. Flights DB has all tables like flights, tickets, seat mapping, or are we doing it is so that's called federation. So when you put each table on a different DB instance, that's called federation. We are not doing federation here. For the term federation, Don Martin's system design primer is where I saw that term at. Don Martin's system design primer is the source I'm quoting for. I don't see that term brought up a whole lot, and it's just something that's kind of second nature and just intuitive to people that use NoSQL databases. You don't really, you think of it so little that you might not even know the term for it, but it's called federations when you have those denormalized tables that you stick on each of their own DB instances. And we are not doing federation for our design on this particular problem. But I worked at Amazon for a while, and so I'm very used to doing the federation approach. It makes a lot of sense in other problems. Good question. What is the key and value for seat mappings cache? So this is we have a 1 to n relationship between a flight, a plane type ID, and a seats and seat options. And so each individual record is actually a key, but you kind of are going to you would query this by the plain type ID. You would do a key range query of the plain type ID. And then the idea is that you would also do a key range query of the flights table. So this one is local on the seat mappings cache. So that's a local query to reduce the IO burden that you'd have on the flights DB. And then this would be a remote query. It's a server call. And so then you would do that to to determine which seats are actually taken. This took a lot of thinking for me to figure out. I really should have been a lot more clear on that. Let's maybe try to even draw it. And then yeah, so I'm going to do that. And then we're also going to do, okay, so we're going to say retrieve all seat options. And then we're going to retrieve taken seat options. That's what's going on here. That took me a lot of thinking earlier today, but that's the spice of this problem, is this little seat mappings thing. Steve from Life Engineered might like this spicy thing I'm doing, but that is what I did. Yeah, that's the fun here. And so I guess you could say that the key here would be the plain type ID, because you're doing a key range query, but really the keys here are actually, like if you wanted a primary key, it's actually technically both is the primary key, because that's what you need for uniquely identifying it. Or if you're doing Java beans, I mean, you can just have a key. You'd have a Java bean for a hash map that would map the plain type ID to a list of seats. You could even have it as plain type ID mapping to a list of seats, since you're doing a locally deployed thing anyways. But like strictly speaking, as a fully normalized database, your key would actually be both attributes. Yeah. Now I can do that next question. Item potency key. There's like the Twitter snowflake algorithm. If you do client local, and I think that's good enough. It could mean that multiple people will come up with the same key, but when it's combined with your user info, that would be an appropriate dedupe, because I mean, somebody else could be generating something with the exact same key ID, but when you have your username in there too, your user ID or some of your user info, that would or the flight. If you have the flight ID with your item potency key, you could go crazy with it and even have the you could even have the user info as part of the deduping process. But you just use Twitter Snowflake, and it's known to have the slightest chance of collisions, but I feel like it would even be overkill to even have any extra stuff, since it's just for a specific flight ID, and there's just such low TPS for the case of airplanes. And that just does something that's a mix of a timestamp, a machine ID, and a randomly generated number. So here, since it'd be run on the browser, I mean, there's a lot more spice to it than that. So it would be more like timestamp plus your own IP address plus your own random number. So Oh, it's based off of Twitter Snowflake though at that point. Yeah. Question, won't tickets have any ID like reservation or PNR number? I don't know what a PNR number is. But on the tickets, you would have your own user info. And so like a ticket ID that would be specific to your own purchase. Every single purchase would maybe have an auto increment ID. Well, since we're using PostgreSQL, I guess you could even have you could actually get away with an auto increment ID on this. You can't do an auto increment ID with a distributed database because then you'd have that would require total order broadcast, which would turn it into linearizability. But in our case, yeah, you can totally use a auto increment ID is totally possible here. And then if we sharded it, you can even use the shard ID as part of the primary key too. So you have your shard ID plus an auto increment ID for determining it. That would probably be a little bit trickier, but if you do manual sharding, I'm sure there's some way to figure it out with PostgreSQL if you do manual sharding for that follow-up. And then again, the follow-up is unrealistic. It's usually you're going to have a very low TPS of writes for airplanes and hotel booking. Got some questions here. How would this system ensure avoiding overbooking? Well, so you're actually allowed to overbook for flights. You are allowed to overbook for flights, which would allow the DB trigger to be a valid solution. But alternatively, when you get to when you click on that button to pull up the seat mappings, you could do a decrement of the count right there when you're pulling that up so that it's reserved for you. But you're actually allowed to overbook here. That's a variation of the problem is avoid overbooking completely. And so then you would have like a cart. It's kind of like the concept of a cart from Amazon.com, is that when you pull it up on the seat selection, then it's reserved to just you, and you do the decrement there. Yeah. It'd be very hard to ensure that you don't have two people that have it pulled up in listings. So if two people are looking at it in the listings at the same time, and there's only one seat left on the flight, and then one guy clicks on it, another guy clicks on it without reloading the page, how are you going to avoid it in that case? That'd be really tricky. You'd be able to call them out on the purchase page when they're trying to do the purchase. And suddenly it comes to suddenly you realize like, oh, hey, this second guy is now trying to do it, and that would push us over the limit. So then you deny his purchase and you send back a hey, there's your purchase has actually failed. And so you could then do it there, but you're typically actually allowed to overbook on flights. The legislation for it is just that if you do overbook, you have to kick somebody. And that would mean that you have to, the US legislation would require that you pay for their hotel for the night and pay for getting them the new flight. But yeah. Would you separate economics, regular, and luxury on the seat mapping? So that would be a thing in the pricing. Oh, that was the thing I wanted to cover, is that when you do a ticketing thing, you do a ticketing update, I want that to also have another DB trigger off to this pricing service. You'd have this pricing service that would then receive a message that like, hey, time to update the prices. I see there's only one left. Let's spike the price a whole bunch. I mean, that's mean, but like, that's totally a thing. So you would maybe have a broker or something to for the CDC, but okay, so we'd have CDC with DB triggers. There's two DB triggers. One of them stays local for updating the inventory. Another one is this.
And then, so this one will somehow figure out a new price for those tickets, and then it'll update the price in the flights DB on that flight for what your listed price is, which is this by the pricing service. Yeah, so that's what's going on there is the DB trigger. Hey, you just booked a ticket. Now let's go ahead and check if we want to update the price for the listing. And did that answer your actual question though? Oh, yeah. On the seat mappings, you would maybe want to have the price listed on each of them individually. I don't know how that would work. I don't want to, so that would be a very interesting question. I don't want to dig into that too much. We already have the seat mapping, which is kind of elaborate. I think I'll call it a day with that and not dig into that. But I mean, that was, I did want to have maybe separate the counters for each of them on the flights table. But this question is like, you know, are we only going to have two different classes? Because I know some flights on those smaller planes, you only have like one class. You only have the economy class because there's only like 26 seats sometimes. So I guess we're just going to leave them unseparated for now. We're not going to handle separate classes of like economy versus business. Yeah, that's a good question. Sorry with my it's change data capture. Yeah, I like to use my jargon. Won't Twitter Snowflake be an overkill for item potency key? Oh, well, it's client generated. It still has a risk of conflicts. So I don't think it's really that expensive. It probably is overkill though, but I mean, it definitely will accomplish what we want. So I don't know of anything less that would, I mean, you could just have like a random number generator, I guess, that goes all the way up to 1 million. I just am feeling Twitter Snowflake with this. There's probably a couple of other approaches. I don't want to dig into it too much. Thanks, Saurav, for the earlier comment and getting to that first. Yeah. All right, let's get back to our design. So we got the pricing service, we got this thing, we got that. What about it's the external payment service. Ooh, that'll get interesting. Yeah, okay. I think I want to do the pricing service. The pricing. So you would need a payment gateway, and those are making those item potent is very interesting. Some people screw that up. It's pretty easy to screw up making it item potent on the pricing service or a payment gateway. So you have a request come in, and then you have your booking service, and let's go ahead and have the steps. Let's have the steps up here. So ticket purchase steps. So one, optionally, first create a record. Requested status. And then we're going to add in our component now for the payment service, like Square is one of the options, or you could even just roll it yourself and just directly call Visa. But we're going to have an external payment service, and this will use something called the auth, the auth capture workflow. Stripe has great documentation on this. I'll write that down. Auth capture workflow. Stripe, or it's either Stripe or it's Square, has great documentation on it. PayPal is another one that I think can be used for it. I just recall that one of these two had really good documentation on the auth capture workflow. So
you could first create the record and then you would get your off key. This is going to have really bad partial failure scenarios. So that's why I'm going to follow up and maybe introduce orchestration. Although first, okay, so you'd also check if you already have a record for your item potency key. So that would actually be step number one, is check if the item potency key already exists and check the status on it for what step you would skip to. And then you can create the ticket record with a requested status. And then 3, you're going to next call the external payment service to get a auth ID. That would be a read kind of thing. It's data flowing in from the payment service. You're getting an auth key. So record the auth ID on the ticket record. So that actually needs to go on our ticket record too, actually. So that's over on tickets right here. We would have our auth ID from the auth capture workflow. I have no idea what that looks like. You would maybe also have your payment info that you've entered before making the clicking on the button. Is that you could have your payment info. You could have that on a separate table, and then you just have the ID of it on the ticket itself. But you need to somehow have payment info captured within the database, and then you would send that over to the external payment service. You know what? I feel like going ahead and making the fancy arrow here. There we go. That's the first call. That's the auth part of auth capture. And then we want to do, where are my steps? Where are my steps? There they are. Okay, record the auth ID over on the flights DB. So that is a second call that we're going to make. So really fancy partial failure scenarios here. And that's why we really need that check first. And then 4, go ahead and run. Oh, record it there and update the status. Authorized. And then you can go ahead and run the payment against the payment service. This is where the deduplication occurs. Every time you call it for an auth ID, it could give you a new ID. But when you do the second step here of running the capture flow, that is where it actually charges. The auth one just kind of holds some money off your card and releases it if you don't actually run that auth ID in the second call. So like if when you're deduping, and if you accidentally generate 2 auth IDs, it will freeze the money for both of them, but it will release it on the one that you don't charge. So it's this is properly handled with the steps, and that's why it's kind of stretched out a little bit more. It makes it look a little bit more elaborate, is that you need to have 2 steps in that call the external payment service from the auth capture workflow in order to make sure that it's item potent. And then after that returns successful, you can go ahead and update status to payment successful. And it's okay if you have a failure between 4 and 5, because all that would happen is that you would run that second call a second time with that same auth ID, and it wouldn't double charge off the auth ID. The external service knows to dedupe off of the auth ID that you're providing it. So this step failing is fine because it will still dedupe on the payment service itself. And then you can go ahead and have your DB trigger will be listening to this the whole time. And after it sees that payment successful status hit, it can go ahead and keep the counter. You would maybe have some kind of scanner thing to do reconciliation of that counter. So it could maybe do a key range query in that triggered step against the flights table that updates the available status. And then I think this one's going to be watching for that payment successful as well in the CDC. Okay, so we've got a lot of steps going on. So this is going to take a while. And if you did the retries on the server side, that would mean that it's going to be a really long call over here.
And so, they're going to have that spinning wheel over here, but it still is like, it's kind of like absurdly long. And so there's some options here for making it async. And that's what I'd like to go into for our next step that I wanted to cover, is that now we are doing our orchestration approaches. That is what I want to get into next. I'm going to check for any questions in the chat. Is Stripe the best for payment? It's the easiest. A lot of small businesses like it because I think it integrates easy. But I heard I think it has higher charge margins. I used to work at a financial services company that handled credit card stuff. And you have a different little, you get an extra little fee. It's a card fee for using their service. So on Visa and MasterCard, I think it's like 7 to 15 cents. Well, if you're using Amex, that adds a 45-cent fee. And usually those fees are they're a hit against your what is it? The merchant kind of sponges those fees. So even though different cards have different fees, it's the merchant that takes the hit. And that is why some places actually do not take Amex. And so similarly, though, Stripe is another thing that has it have a little fee. And I heard that they have a really big margin for chargebacks or any kind of merchant disputes. And so it's maybe one of the easiest ones, but it would have a higher margin. So I mean, there's a trade-off there all of its own, and that's a little bit outside the scope of this video to give you like really solid answers for, but it's easier to integrate with, maybe some higher charge margins. So I believe that Stripe's probably not what they use for airlines. They might actually even use direct integration straight to Visa or MasterCard or something. That might be a little absurd, but I mean, I'd see them doing something a little bit lower level that would really clamp down on those fees a little bit. I see, are we using step function for distributed transaction or two-phase commit? I'm actually going to add that next. I wanted to add in AWS step functions. We are not doing two-phase commit here. Yeah, we're not. Each step is on its own. This is a little bit more like sagas. This is more like sagas. Yeah, it's more like sagas. And I'll show you how this looks with orchestration next. Okay, let's go ahead and copy paste this as a checkpoint. And again, I share this with people on Discord. I'll go ahead and post a link to this after this is over on the YouTube channel. I need to treat you guys better than the Discord people since I've made it harder to join into it. So that's our checkpoint. And now I'm going to add a orchestration component to this. So we are going to go ahead and copy that. Now I'm going to paste it again, and then we will have a AWS steps. We'll be doing this instead for orchestration. There's a couple of options for orchestration. Another one is Netflix Conductor, which has really great documentation, but you gotta then host it yourself, which is a huge pain. It's like trying to do your own hosting of Postgres or something. Like, why do that when you can just use something that like already is a cloud managed service? So this will do all those steps instead. And so you would maybe have a WebSocket you'd have open with your service. You could have a WebSocket open, and then you would have the request come in, and then it would make a call over to the orchestration. So I said WebSocket, but I think that polling is probably more optimal here. So that's why I'm also going to cover that approach. But we're going to start with just the WebSockets one that is going to be horrifically expensive. And I'm going to do a little bit of hand waving on how you're going to map it back to the service. So you're going to go ahead and you're going to kick off the steps function, which will look a little bit like, I'll go ahead and draw the fancy arrow. So it'll be like that. It's the booking service calling AWS Steps. And then AWS Steps is going to have to do a little lookup of the proper machine ID for where the WebSocket is. Actually, it might only be one machine. You only need one machine for handling the scale of 10 TPS. So it could just be one, and then you just use service discovery to make sure you know the right IP address. But you'd have that, and then it would actually be, after it does the whole workflow and stuff, you would do a call from Steps to the booking service to let you know that it has properly executed or that there was a failure. And then so you'd call that, and it would go ahead and send the message to the client over the WebSocket. But that's the WebSocket approach. I feel like that's a little bit unrealistic, and you probably just go ahead and do polling, which is easier to implement. And so you usually don't do polling for like WhatsApp because it's a really massive scale. And so then that would be really expensive to do. But polling is easier to set up, I believe. I'm fairly certain polling is a lot easier to set up than a full WebSocket thing. So I think that would be a lot more realistic in this case with the flight booking thing. And you can even just have it as captured and then just let them know over an email notification. So this will be, I'll add a label of orchestration with web sockets. And then we want to do another approach where it's using polling instead. It's a little bit more asynchronous, and you don't necessarily have to can tell them message received, hey, we've received that you requested this flight, and then you would just send them an email later on saying, payment successful, here's your confirmation email, as opposed to, hey, there was an issue with your payment method, try again with proper payment. So like that's another thing to do. And then this is orchestration, it'd be async orchestration with polling. Short polling, not long polling. We would do short polling. Long polling is absurd because you still have to hold the connection object, which is like, it doesn't, you're not saving a lot of complexity in this case if you do long polling. So you're going to do that approach over here. Hold on. Okay. So we have that. You would maybe just do, so you have what you could do. So you kick off, you create the record directly. You could create the record directly, and then you would talk to, you can just kick that off directly. And then have this over here. You would kick off the steps thing. It would run, it would return before it's done running. So it's kind of like a write to a database. And then it starts running its stuff asynchronously, like after you've returned. So you write the record, kick off the AWS steps process. And so it's not waiting for all of these calls to finish before it returns a 200 success over here. And then you would go ahead and return your 200 right here to the client like that. And then you could do polling. So I'm going to have the booking status service. Let's go ahead and move this so that it's like this. You can have your item potency key. Going to have, or I didn't have to move that down as far there. So you got your item potency key. You've made your call, you've made the first call to the booking service. Let's draw a fancy arrow for that. So you made your first call to kick the thing off, and then you're going to have your booking status service that you're polling for your result. You're going to be polling this one for your result. I'll write that. Polling. Short polling. And let's have it. So you would talk to the database directly in that call. I'm just giving myself some space here. So have that. And then when you're polling this, it's going to be checking this database like that. It's just going to be trying to read from the flights DB. Let's change that up to a proper arrow there. Yeah, so you have a request come in, it checks the flights DB for your status. It's checking the status that you have on your ticket table. And then it returns the 200 success. And so if it's not in that status, it'll just keep showing that loading thing until you do a poll and it returns back with a payment successful or a payment failed. And then this thing can also have, if you don't do the polling, so the whole polling thing right here is optional. Could instead, I'll go ahead and show that. We could even have 3 approaches over here. So then this one will not have the loading spinner. It'll have a very quick async thing. And then instead of having the polling, just return 200 success. You'd say like, hey, watch for the email. And then when the orchestration thing is done, you would have an email notification. It's going to have a notification service like SNS. Rolling it as a problem from scratch is a problem all of its own. Make sure to ask your interviewer whether SNS is appropriate or if they want to actually have you roll it. I've heard people that interviewed with Facebook had questions where the interviewer really did push them to roll notification themselves, which sounds, I mean, it's not that hard, but I mean, it's still a bit of a pain. So then you have your confirmation email. Just like that. Boom. There we go. I'm pretty happy with that. I don't see any questions in the chat. Yeah. Cool. All right. I had one last thing, and I'm feeling it tonight. We are actually going to go ahead and roll the high right volume. I'm going to show you how to shard this. So we've got all of our tables here. We've got the flights table. It's got flight ID on there. We've got tickets. It's got flight ID on there. Seat mapping is a thing that can be cached. It's like you can federate it out. It's not really going to be updated. You're not writing to the seat mapping. You don't even really need to worry about it. So what we're going to do, I'm going to take this checkpoint, paste it over here. And so what you can do is you can just shard the flights DB over that flight ID attribute. And so then you have, it's manually sharded PostgreSQL. That's why I'm feeling PostgreSQL in particular with this problem is that with DynamoDB, you can't like manually shard it to specify that you want multiple tables. You want to do a non-federated thing where each leader has a slice of multiple tables like that in order to avoid the distributed transaction. So here, I'm going to draw it here. We have this, have it like that. I'm going to move it over a little bit more. And then we're going to have our second one like that. And so you have your lead nodes and you have to figure out which one you actually want to have your transaction against. And then each leader also has its own replicas. You can't do shared replicas. So then those are the replicas for that one, while you would have a different set of read replicas for a different one. So then this one also has its own read replicas.
should look like that. So this is the overscaled example. We're gonna call it unrealistic approach, unrealistically high write volume approach, because you're not necessarily going to need to actually shard it like this a lot of the time. It's unrealistically high write volume. So it's like if you actually had 1,000 TPS for the writes and you have these expensive transactions and multiple hits going on for each transaction or each ticket purchase, might need to shard it. And yeah, anyways, unrealistically high write volume approach. Let's go ahead and zoom out, and this will probably be the thing for the thumbnail. Or not, we'll see. It's either going to be this one or the ones right before this that didn't involve sharding. But this is how you would handle it if you needed to shard. All right, I'm going to wrap it up. So I'm going through our last questions for the night. Feel free to drop any questions that you have and we'll wrap it up. See, it's like normal, regular, economy, 1,000 seats, and have a weird CDC iteration. I think you're talking about the class of ticket, like economy versus business. And yeah, I'm just not really doing that. This problem, I mean, it could be like an extra, when you're doing the seat mappings, on the seat mappings thing, you could even mark it as economy or luxury. So where is the seat mappings schema? Where's that schema? There it is. So you can actually store your class information here. That would be where you would have it. Yeah, and I think it's fine just right there. Can you handle retries on the server or on the browser? Well, you gotta, so in this case, for our third case with the polling, or this is not the polling approach. This one was short polling, and then this one was the async orchestration with email confirmation. That's a more appropriate name. So in this case, you would need to retry on the browser until that first one goes through, perhaps. Yeah, you would need to retry until this one returns a 200 success, which it will not give until you have a success in kicking off the AWS steps function. So you need to retry on the browser until there. Otherwise, all the other retries for AWS steps will automatically handle retrying for you. It's like Lambda functions, but it chains them together on your, it manages the chaining for you. So there's retrying on both of these two. And then for this one, it would be, well, so it's, I have the dedupe ID. It's like if you ever get a 404, like if your booking service node that you're hitting goes down, you might want to have at least 2 booking service nodes. I guess you might want to have at least 2 just for the N+1 thing that I talked about earlier in the video. If it goes down while trying to handle your stuff, you would of course still need to handle a retry off the browser. Just, there would always need to be retry stuff in that scenario. And then for the would you have retries on the booking service though, in the case that it gets a dropped packet from the AWS steps function? It depends. You could return a 500 error or a 400 error when this thing is having issues and it's not getting back to you. AWS steps though, it's a Amazon AWS service, so it shouldn't have a whole lot of downtime. I mean, it happens, but as an airline, you shouldn't really try and build resiliency for AWS steps. I think that might be overkill for that kind of thing. In fact, there was the one flight service, what was it? Delta or United or something just did horrendously over this last winter. They clearly are not building resiliency for AWS steps and some extra stuff. So it's anyways though, browser and server side. You get the 200 and server side just from AWS steps, just kind of like automatically doing that. Okay, no, just pick a seat and skip the CDC. I don't know what that's about. The host now. I'm trying not to be too publicly open about working at Apple, yeah, like, and having my name here just so that they don't like come after me and say like, hey, stop running the YouTube channel. That's why my name's not in the channel name. That's why it's System Design Fight Club instead. It's thousands of millions of normal regular seats in the CDC iteration of green. Not familiar with that. Seats mapping cache is usually not changed. Yes, that's why I did the caching. So I'm totally cool with the caching because you're never going to change the seats mapping. It's like you would get like it would only change whenever there's a new type of plane that comes out, like Boeing introduces a 797 or something. So like that one even might be the schema or the entries on the seat mapping cache might even just only be changed manually by like an engineer. They might like hard code the change into XML data or something if it's like Java beans. So yeah, it's hardly ever going to change. Yeah. Explain about the business purpose of seat mapping. So it was you're first going to get you're going to retrieve all the seat options. So like for each flight, for each type of plane, you know, a 787 might have like 60 to 80 seats. So you have all the seat choices, 17A, 17B, you know, all rows 1 through 40 plus that A through D combination. And then as opposed to other ones, there's like, what is it, 747 or some kind of small planes. It's only like 20 to 30 seats. And so then it's well, for 737, it's, what is it, 8 wide, A, B, C, D, E, F, G, H. It might be like up to H, while this one would be like plus so it'd be, what is it, 20 rows plus A through D, like that. And then it has all the combinations stored on whatever the plane type ID is. Is there any special I don't understand the question. You might be asking what's special about AWS step functions. It's basically AWS Lambda, but the retries and you can have this like DAG, directed acyclic graph of the steps and how they're related to each other. And so it makes it a lot easier to think about retries. But so it's that, but the retries and partial failures and DAG of dependent API calls is way easier to reason about. So internally at Amazon, there's even this thing called herd. So herd, which is Amazon proprietary. You can literally visualize your API call graph visually. There's like a visual tool. You like write your API calls in XML. You write the chain in XML, and then you can visually see it on this visualization tool they have for showing you this like directed acyclic graph of the API calls. So the advantage here is that the steps provides on top of Lambda is that it just is way easier to reason about those retries, partial failures, and the chain of calls. Yeah. All right. I appreciate the appreciation for the videos. It definitely takes a little time on these, and yeah, it's nice to have other people that are passionate about system design too. Okay, I think I've got everything. You guys are probably free to drop off. Oh, what are the advantages of federated data design? Independently scale tables. Independently scale tables. Yeah, it's mainly just easier to scale things up and down. It's what you do on, you usually do it before sharding. So it's typically done before sharding. I would just read Don Martin's System Design Primer to check it out, but it's you typically have to do it before partitioning, unless you do manual partitioning. So it's the only way you like have to do federation if you're not doing manual partitioning. And manual partitioning is a pain in the ass because you have to set up the nodes and handle the scaling up and down by hand. It's not just done through an auto scaler. So if you're going to do a managed auto scaling solution, you have to do federation. Scaling solution, it mandates. Well, so Spanner handles it for you. Spanner doesn't require federation. It typically mandates federation. Spanner is a slight exception. But I don't, Spanner's also weird. It doesn't do the partitioning thing like what I did with the overscaled approach that like is overkill for writes. Spanner doesn't do anything like this where it's sharded by flight ID to avoid distributed transactions. Spanner still requires distributed transactions. Still does distributed transactions, unlike what we do in this problem. In this problem, you managed to dodge distributed transactions for the some of the parts. Well, so we also do sagas though, but we don't have to do like a 2-phase commit or 3-phase commit or Paxos or anything like that. We're not doing consensus here, while Spanner does distributed transactions with Paxos, and we're not doing that here. I am not sending the invitation link over YouTube, sorry. If you can find me on Blind, I'll send you it though. To add a yellow pages DV. I don't know what that means. All right, I think we've managed to knock out all the questions. Feel free to drop off. I think we can wrap it up now. Thanks for joining me, guys. I'll see you next time.